Site and context modeling. So the format in this module is that the workshops tend to build upon the content in the lectures. We sometimes watch some videos. Later on in the course, from next week on, not today, but from next week on, I will I'll situate myself here after the workshop, and if anybody has any questions or queries, they can come up to the front and spend some time with me after the session, okay? But today we won't do that. I don't think you've had enough time probably to try the software yet. Okay, so this is what we're going to look at today. We'll do some of this with me demonstrating in Revit, and some of this I've got a few videos just to show you. Okay, so it's just really building upon a few of the tools that we've already looked at for building the site. Okay, let's go into Revit. So this is our site topography that we built. That was built in the video that we saw last week. Okay, so there's our topography there, and it's not got anything on it yet. So let's first of all just look at how we split the site. Now we did actually use this split surface tool to trim the edge of the site, but we'll just use it now to make some roads. Okay, so what we'll do is just zoom in here, ZZ, and we just want to make this road surface here. Excuse me. Now there are two ways of doing it. You can either do it by splitting the surface, or you can do it by using the sub-region tool. We'll do it first with the split surface tool. So select my topo surface, and I've hit the split surface tool, and it's changed the context menu now to, it's asking me to draw some lines up here. Okay, so let's just zoom back in a bit, and let's just draw some lines here along our road. Okay, that will do. Accept that. And what it has done, as you can see in the 3D view, is it's split our surface into two different surfaces. Okay, now if we just do that again, go back into our plan view here, zoom in, and go back to the massing and site, split surface, again, select our topo surface, and it's actually this one that we want now. Sorry, do that again. Split surface. Select our topo surface, and if we just repeat that by drawing lines this time along the other side of the road, okay, then what we've now done is we've split that surface. That road surface is now a separate part of that topo surface. So it's a separate entity. You can now give it different properties, and you could change its height. So what we're going to do now is just maximize zoom extents here. I'm going to hide that raster image, so right click on it, hide in view elements, so just hide that for now, we don't need that. Zoom in, there's our different surfaces, and I'll just show you now the section tool, and then we can look at moving that road surface. So in a plan view, if we go up to the top to the view tab, up here, and section. So we'll create a new section, and what I need to do is click and drag to define that section. So it's done it. It's not showing me very much, but it has done that. And this is where you start to see the real benefits of working in a 3D environment, particularly when you have buildings modelled. If we now just double click on that section line, it takes us into our section through that site. Okay, and because it's a 3D model, this is not a 2D drawing of a section, it's live, three-dimensional information. WT, Windows Tile, and I'm just going to select that road surface. What I did there, I'll just deselect that for now. Rather than trying to find, when I was in the section view, rather than trying to find that piece of road, which you could, but it'd be quite tricky, I did WT, Windows Tile, ZA, Zoom All, and it's probably going to be a bit easier to select it in the 3D view. So I can have all three views open at the same time. I've selected it in one view, but it will stay selected in the other view. If I now just maximize that section view. So I've got that road surface selected, and what I want to do is just drop that road down a little bit, just to sort of create that impression of a road surface which is just below the pavement level. So if I just go over to our Modify tools and select Move, I can now click and move that road surface. So if I drag it all the way down there, obviously that will go way off the model. So if I just Control Z, undo that, select it again, move, click, start to drag, and while I'm dragging I'm just going to type. So I'm going to drop that 300 millimeters. You can't really see very much there, but if I go WT, Windows Tile, ZZ, if I just zoom in now, you can just about make out that I've dropped that down a bit, okay? It's not very obvious. Windows Tile, it's more obvious when you start to look in the plan view. Because you see now the contours are registering the fact that that surface has dropped down. So the accurate contours now no longer follow across the road, but they register that we have lowered it down. I'm just going to hit save on that. Now the other thing that sometimes that's useful for is if I just switch some shadows on, just change my sun settings there. Let's just drop that down to a sort of early morning in winter. You can just make out there that depression in the road is giving us a shadow. Okay, so that's one way of creating that road. Okay. Now the thing to bear in mind is, as I keep saying, in this module we're interested more with simulation and analysis. We're kind of less interested in the more the kind of visual styles of how you export imagery from Revit. Okay, but equally you'll see when you look at some of the examples that I've put on Mole of the reports, some of the really good reports are the ones where the students, they've invested a little bit of time in making that site model look good. So just getting it right, getting the right level of detail. A few people have put cars in it. They've put a bit of street furniture just to make it look like a slightly more realistic site. Okay, so that was splitting a road surface. Now we need to get our topo back on, which I've hidden, our map, sorry. If I go down here to reveal hidden elements, that takes us into this Reveal Hidden Elements dialog box. It colours it red, just so that you know you're not in a normal editing window. If I just select that map and if I click on the unhide element here, that will show the map again. If we go back to this X here, we can quit out of that command. So there we are, back on our view. Let's just make this a wireframe again so we can see what we're doing. Just zoom in a bit there. And this time we'll make a road, and this time we'll make it by using the sub-region tool. The difference with the sub-region is it doesn't actually split the surface apart. It just allows you to color it differently. So we hit that tool, and again it prompts us here to start drawing lines. Let's try using that line, see if that works. So I'm just doing it roughly, just sort of rushing a bit. So I've drawn that line. Okay, let's just hit escape there. Let's draw the line along the other side. I'll just do it quickly. Okay, now I'm sure we need to join the two ends, so if I just get a straight line here, zoom in a bit. There's one end. I think I missed that. Just undo that one. It will need a complete shape. If you don't join the ends of it, I'm sure the command will not work. So hopefully we've joined those ends now, and we click on the accept finish edit mode. Okay. I'm just going to hide our map again. So there's the road that we've created. You can select it separately, you can change its properties, but it's not split from the surface. So if we change this to a consistent color render view, select that again. If I go into its materials over here, and we change it to a different material, so let's say we'll change it to asphalt. Okay. Deselect it. It now has a different appearance from the rest of the topo surface. Okay. I'll just save that. So that's just a few simple tools in terms of starting to make this surface more realistic. Okay. Let's put our map back on. So reveal hidden elements, select our map again, unhide, and come back out of that command. There's our map, and let's go back into a wireframe so we can see what we're doing. And what we're now going to do is use the building pad tool. So what you can do, because we've built this sloping site, when you want to position a building on it, whether that's a sort of accurately modeled building or just a conceptual mass, you probably want to put it on a flat site. Now, I mean, you don't have to. For conceptual massing, you could just push that building through the surface, but sometimes it's neater to model that flat bit of terrain. So what we're going to do is we'll select our topo surface, we'll hit the building pad tool, And again, it asks us to start drawing lines to define that pad. So I'm just going to roughly, I'm just going to do it quickly. I'm just going to roughly sort of make a flat area here in front of the arts tower. Okay. Now the important thing is that you do need to tell it what height. So it's asking what level is that building pad. Now at the moment it's referring to level 3, and it's offset 0 from level 3. Now I happen to think that should be about minus 16,000 from level 3. Can't see it, but if we just go into a 3D view, okay, if we accept end the command here. Oh, I've gone over, okay. So it's saying it can't do it because I've extended beyond the edge of our surface. So I think what I did is I've gone into our road up here. Okay, so that's why it's not having it. What I can do, because you're still in the command, you can still just edit these lines. So if I pick on that line there and just drag it, it knows that it will drag the joined lines with it. So if we hit accept now, it should have worked. WT, Windows tile, I just maximize our 3D view here. Okay, so it's made this horizontal pad. Okay, and it's clearly not quite right because it's too high at the moment. But if I just select that pad, if I just click on it, trying to. Okay, so I selected that pad. I had to use the tab command there to tab through different items to select. So it's a bit too high at the moment. So if we try, let's just knock it down a little bit. Oh, gone the wrong way. Minus. Okay, so I just dropped it down a bit. So we now have if I just pan around, we've got a sort of flat bit of site now where you could put your buildings on. Right. Now we're going to quickly look at massing some buildings. Now I'm aware I'm going through this quite quickly, but of course you can watch this again and practice in your own time. So let's go back into let's get rid of that section. Windows tile, ZA, zoom all. Let's go back into our plan view over here and let's have a go at massing a building. So let's do the arts tower.
Sorry.
Yeah.
In the property window of building pad, the default level is level 3.
It did default to level 3 probably because that was where I previously set it.
So
you can change it. Yeah. I mean, at the moment our levels don't really mean anything. Once you have a building and you know that level 4 means a certain floor in the building, then you can start to reference from that floor.
Okay, so the building pad will change automatically according to the building level.
No, not the way I've set it there. It will if I went into level 3 and changed level 3, then yes, everything that I've defined from level 3 will go with it. Yeah. Okay. Okay, so we want to now start massing some in-place masses as part of our site. Okay. We go to our massing and site tab at the top here. and we've got in-place mass. And you can do some very fancy, very complex things with this. Today I'm just going to do some very simple buildings, and I'm going to point you at some further tutorial videos if you want to do more complex modelling. Place mass. Arts Tower 1. And just draw a shape. Okay, create form, solid form. So it's created that form, and what you can then do before you finish the mass, you can either in the 3D view simply drag the top, or if you click in the dimensions, you can type a dimension in there. So let's put 80 meters for the Arts Tower. And now if we click on the finish mass, we create our mass form, okay, which is the Arts Tower. So as I say, I'm not going to go into all the complexity of all those tools. I'll point you to some more videos. Really, it's a case of your level of interest. If you want to just model basic massing, you can just do what I've just done there. Very simple. And for most energy simulation and daylight simulation, that is good enough. If you want to get into more complex shape creation, these videos will give you some more advice on that. Okay, we haven't got time to go into that. It's not really the purpose of this module, because this module is more about simulation rather than the sort of detailed level modeling. Okay. Right, so we've covered our basic, we've built a site, we've put roads on it, we've made a building pad, we've put a building on it. Just a few other things that you can start to do. You can place site components. So site components are elements which Revit defines as a site element, and the most obvious one is trees. Okay, so I've hit site component, and in my drop down menu over here we have all these different trees we can position. So I've clicked on that one there, and if I just zoom in a bit, what Revit does is it intuitively puts those trees on the topo surface. So it doesn't put them floating up in the air. It knows that you want them on the topo surface. Okay? So there's some trees. Just maximize that. And if I put some shadows on, you get some shadows. Now you might think they look like slightly funny trees. Okay? And they do. They do. Now these are, if I just click on one, click on that one, I'll just change that one to a different tree. Okay, so it's a slightly different tree. Okay. Now, they're actually quite clever. These are called RPC, and that stands for Rich Photographic Content. Now, what that means is basically when you do a render, it will substitute out the tree that you're seeing on screen for a photographic content. And this can be quite powerful because it means in your normal editor, you can just view these very basic trees, which don't slow your computer down at all. But when you come to render, you don't see that tree, you see a full photographic tree. And it's the same with people. You can get cars, you can get other elements. You have to download them off the internet. So, they're quite useful. The ability that they snap to the topo surface is useful. They cast shadows, which again, is quite useful. Some people don't like the look of them, and I can, fully understand that. obviously you'd be free, you could make your own trees if you wanted, but again, for the purposes of simple simulation, these are perfectly good. And when we come to look at daylight simulation and visualization, they are actually quite powerful. If I can just quickly find an example of a render here. You can't really see it, unfortunately, but what I was just trying to show you is this person, for example, you can just about make out through the windows. That, again, is a rich photographic content person. So in the Revit file, it looks like a piece of cardboard, but it renders like a person. You can't really see it, but there is a tree just hiding behind those blinds, which, again, is a rich photographic content tree, an RPC tree. Okay. Now, thing to bear in mind, we're not talking about professional standard visualization here. We're talking about a quick visualization that allows you to kind of get a feel for the environment, and you can then also conduct the daylight. So these are the same image. One is a daylight simulation render, and one is a sort of visualization in Revit. Okay, but those RPC elements in Revit, you'll find that they're quite good for a lot of what you want to do. If you were then taking this into 3D Studio Max and you were doing real high quality renders, you would obviously get rid of those trees and you'd substitute something else in, something better quality. But I'd say what you need to be slightly wary of is if you start importing hugely complex trees into Revit, your simulation will not, it will have problems. Okay. Simulation for energy and for daylight, it will not cope if you have hugely complex files. That's why you bring in these trees rather than a better tree which has 4,000 individual faces on it. Okay, so that was trees very, very quickly. Right. Just going to run through a few more things and then we'll call it a day. Okay, STL exporter. An STL file is the file format that you need to send to a digital 3D printer. So the Z printer, or if you want to send something to the digital CNC router, you need an STL file. Now Revit 2014 does not natively have an STL exporter. So you have to download the plugin and install it. Okay, and it does work. Let's just quickly watch this video. I need to plug this in.
For printing machine, or for example, to be sent into.
Bear with me a second, I'm not getting any sound. I'll tell you what. I won't, rather than play about trying to fix. I've already put the link for this on Mole, but this video will take you through. Very simple. It's only a 2-minute video. It'll take you through how to export an STL file, and then they demonstrate opening it in the Z printer software, just to show how that works. Okay. I think it's just quite an important one because you could spend a lot of time in Revit building models, and then you can't actually send the thing to the printer. Okay. The next video here, which I won't, we'll not watch it now because we're running out of time. This one is a little bit more information about placing site elements. So again, he goes through trees, but what he does in this video is he goes through a few more of the sort of options on placing trees and some of the different ways of importing different types of tree. Okay. He also discusses in here the different parameters of those trees in terms of whether they are casting shadows or not. So you can view that in your own time. And the next one, this one's really optional. This is up to you. But I mentioned in the previous video, I mentioned about if you have three-dimensional site topography, three-dimensional lines, you can make a topo surface directly from that three-dimensional information. So the way that we've done it, which was this quite simple way of doing it by just picking points, is fine. But you can also do it by importing a more detailed set of three-dimensional information in. Okay, so there's a short 5-minute video on that. You know, if you find some of these tasks you might not need now, but if you're halfway through your design project later on in the year and you have a bit of a problem, you might find it useful to refer back to these. Okay, so that's that one. And the final one, then we'll stop. Okay, this is a very good Revit tutorial series. Now it's Revit 2011, but it's completely relevant to 2014. There's very little which has changed. Now, the reason I introduce this is because this is well beyond the scope of this module. This module is not about teaching you Revit. This module is about simulation. Okay, but I know what happens in many years is a lot of students are really quite keen to learn Revit, and they want to spend the time learning it, and then they want to use it in their student projects. So I'm pointing you at these videos because I think these are some of the best, and these take you through step by step in very short sessions a whole range of tools in Revit. Okay, these are Autodesk videos made by Autodesk. They're very, very good, very thorough. So I'll link those on Mole as well, and I just encourage you in your own time to have a look through those and to forward your kind of skill level through using these videos. Those of you who are taking the BIM module in semester 2, again, this will be incredibly helpful. If you can spend a little bit of time learning these tools now, then when you get to that module, you'll really be equipped with some good skills. Okay, I'm going to stop there. I've got 5 minutes now if anybody wants to raise any questions. I'm not going to stick around for today after that, but in future weeks I'll stay here and we can look at anything on the computer that you'll have any problems with. So, anybody want to ask anything now? Yeah.
For our projects, we will have information about the context, for example, kind of buildings.
Yeah. Yeah. Good question. What we have is to be honest, what is normally perfectly adequate is simply to use the sort of bird's eye views you can get from Bing or from Google Maps. Now, if you're working for a practice, they would probably commission a LiDAR, a 3D laser scan, and you'd get very, very accurate three-dimensional information. But for our purposes, normally all I recommend is simply look at the aerial maps, look at the look at the buildings, and you can quite easily make good estimates of building height. You can look at the arts tower, you can measure a floor, count the number of floors. It's good enough, to be honest. I mean, in a practice environment, you would quite often you might even buy the pre-made site model anyway. You'd pay a company to produce that for you. But for our purposes, just estimate a little bit. Yeah. Okay. Any other questions? Okay. So I've thrown quite a lot at you, and obviously I wasn't here last week, so there's those videos to watch as well. So you need to now start working through the demonstrations, okay? Start practicing, start building these site models yourself. Start everything that I've shown you, start doing it, start playing with it. Next week, if you've got any problems, bring any issues with you, bring your file on a memory stick, we can plug it in, have a look at it. If you have any real problems midweek, just send me an email, okay, and I'll arrange to see you. Don't knock on my door with a Revit file, okay? Because normally, by the time I've stopped what I'm doing, fired at Revit, loaded it in, try and figure out what's going on, it can take half an hour, and I can do that, but I need to program that into my calendar. All right, thanks everyone.